Good day, grade 11 learners. Welcome to Life Sciences lesson. My name is Ntombi Dladla. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. I hope you'll enjoy it. Okay, grade 11s, as I've introduced myself, I'm Ntombi Dladla. So today we are completing the chapter of animal nutrition, and we'll be focusing on assimilation, egestion, as well as homeostatic control of blood glucose levels. Let's quickly look into it. Now, before we can start with our topic or today's topic, we need to know that the digestion has 5 different steps. The first step will be ingestion. Now, ingestion, that means it is an intake of food, and ingestion usually takes place through the mouth because that's where the food is taken into. And then the second process will be digestion. Whatever the food you have taken in should be digested, and that food will be absorbed. And remember that the absorption of food will take place in the stomach as well as in the small intestine. After absorption, we'll be having assimilation. Now, when we talk of assimilation, we are simply referring to the absorption of nutrients by the cells of the body. After assimilation, the last stage of digestion will be egestion. So egestion is simply it simply means that it is the expulsion of what? Of all the undigested food through the anus to the external. Now let's look into our digestion. What do we talk about? What are we talking about now when we talk of digestion? Now, digestion in general means the breaking down of what? Of food particles, or of large food particles which are not soluble or which are insoluble. So these large particles which are insoluble should be broken down into what now? Into smaller substances or into smaller molecules. So this is basically what digestion means. Now, in a nutshell, we can safely say that digestion is the breaking down of large food molecules into what? Into small food molecules. Now, digestion can take place into 2 different stages. The first one will be physical digestion. Now, when we talk of physical digestion, we are simply talking about mechanical digestion, which can take place in the following: through mastication. Remember, when we talk of mastication, we are simply talking of what? Of chewing. When we chew food, we are masticating it, meaning that we are breaking it down physically so, or mechanically so. And then the other process of physical digestion will be stomach churning. Now, when we talk of stomach churning, we are simply talking about the contractions as well as the relaxations of what? Of the stomach walls, so that food can be able to be absorbed, or that food can be able to be broken down. So that process is called stomach churning. And then the last process under physical digestion is peristalsis. We've spoken a lot about peristalsis, grade 11s, that when we talk of peristalsis, we are simply referring to the downward movement of what? Of food particles. Now, peristalsis is taking place through the esophagus. How so? When the walls of the esophagus are contracting or are relaxing, they force the food particles downwards. In other words, they push the food particles towards what? Towards the stomach. So that process is referred to as what? As peristalsis. So these are the 3 processes of the physical digestion or the mechanical digestion. And then the second part, or the second example of digestion will be chemical digestion. Now, when we talk of chemical digestion, this is a type of digestion which is made possible by enzymes actions. In other words, enzymes are responsible in breaking down what? All other food substances. So chemically so, not physically so, not mechanically so. So this type of digestion is called what? Chemical digestion, and is made possible by what? By enzyme actions. Now let us look on how enzymes are breaking down different nutrients. Let's start first with proteins. Remember that proteins are made up of many different amino acids. So we know that the amino acids are the monomers, are the building blocks of what? Of proteins. Now these amino acids need to be broken down. Now there comes in the enzyme. The name of the enzyme that breaks down the proteins or the amino acid is called protease. So what is the function of the protease? The function of the protease is to break down the protein molecules into what now? Into the building blocks, which are the amino acids. The second nutrient that will be broken down will be the starch molecule. The starch molecule is made up of many glucose molecules, meaning that these glucose molecules also need to be broken down by an enzyme. Now, which enzyme is responsible of breaking down the carbohydrates? It is the enzyme called carbohydrates. So the function or the main purpose of enzyme carbohydrates is to break down the carbohydrate molecules. And how is it breaking down? How is it breaking it into? It breaks it into what? Into smaller particles of what? Of glucose. Remember, the purpose of digestion is to make all these large molecules to be in smaller molecules so that they can be easily absorbed. And then the last nutrient that will be broken down by an enzyme is the fatty molecule. So the fatty molecule, remember that the fatty molecules are made up of the fatty acids as well as the glycerol molecules, meaning that these fatty molecules need to be broken down into smaller pieces. Now there comes the what? The enzyme. And what is the name of the enzyme that will break down the lipids? It is enzyme lipase. As you can see that this enzyme is named after what? After lipids. We know that when we talk of lipids, we are simply talking of what? Of fats. Now enzyme lipase breaks down the fatty molecules or the fat molecules into what now? Into glycerol as well as fatty acids. So these are three different types of enzymes which are breaking down all these large molecules or all these large nutrients into smaller nutrients. Now let us quickly recap on the groups of enzymes that we've just studied about right now. The first one is enzyme carbohydrates. Where is it produced? It is produced in the mouth. In other words, in the mouth, in the saliva, this enzyme can be produced, and then it will be able to break down all these large molecules into smaller molecules. And then it is also produced by the pancreatic juices, and then it is also produced in the intestinal juices. And then the second enzyme is our enzyme protease. And then where is it found? Where is this enzyme found? It is found or is produced in the stomach. It is also produced in the pancreatic juices as well as the intestinal juices. And then the last enzyme is our enzyme lipase. Where is it produced? It is only produced in the pancreatic juices as well as in the intestinal juices. Now, let us quickly recap on when we were doing the structure of the alimentary canal. We touched or we talked a lot about the small intestine. This is our small intestine, and then we have learned that a small intestine is lined with so many linings, and then in the inner part of the intestine, that's where we are having the finger-like projections, which are called the villi. And then we have learned that the villi is responsible for what? For the absorption of what? Of the nutrients. Now this is basically the enlarged structure of what? Of the villi. Now the main function of the villi is to do what? Is to absorb is to absorb the what? The nutrients. In other words, all the nutrients which we get from different type of foods that we eat will be absorbed through the villi, where in the small intestine. However, the villi is made in such a way that it is able to perform its function. What is the function of the villi? Is to absorb what? The nutrients. Now, how is villi structurally adapted, or how is villi structurally suitable to perform its function? What is the function? The function is to absorb what? The nutrients. So how is it made so that it is possible for it to absorb all these nutrients? Number one, when we were doing the structure of the villi, we have seen that the villi is lined by what? By the thin epithelial cell, or by the thin epithelial wall. So the thin wall that is lining our villi, it makes the diffusion of the nutrients to be what? To be possible. Remember, diffusion can only take place on a thin wall. If the wall is thin, meaning that the nutrients will be able to do what? Will be able to diffuse through a thinned wall. So this is one of the structural adaptations of what? Of the villi to perform its function, that it is made up of a thin wall, and then this thin wall increases the absorption of the diffusion of what? Of nutrients, meaning that the nutrients will be able to diffuse through the thin wall. Secondly, we have learned that the villi is made up of what? Of microvilli, meaning that these microvilli are able to increase the surface area of what? Of the villi, meaning that they make the surface area of the villi to be what? To be large. So if the surface area of the villi is large, it means that it will allow what? A rapid diffusion of what? It will allow a rapid diffusion of what? Of nutrients. So it is because of what? Because of the microvilli, which are enlarging, which are making the surface area of the villi to be what? To be large. So if the surface area of the villi is that large, it means that there will be a rapid diffusion of what? Of nutrients, meaning that the nutrients will be able to diffuse rapidly. So because of what? Because of the large surface area, which is brought by what? By the villi. Remember, the villi are also found on the structure of what? Of our, the microvilli are found on the structure of the villi. And then this villi is also made up of the lectile. So this is our lectile, and then the lectile is made up of what? Is made up of the tiny lymphatic system, meaning that if it is made up of tiny lymphatic system, it will allow the absorption of what? The absorption of these fatty acids as well as glycerol. Remember, these fatty acids and glycerol are the monomers, or are the building blocks of what? Of fat, meaning that those nutrients will also be absorbed, will also be able to diffuse and then be absorbed by what? By the lactic structure of what? Of the villi, because it has that tiny, it has the very tiny what? Lymphatic system, meaning that it allows the diffusion of, or the absorption of what? Of fatty acids as well as glycerol. And then lastly, our villi is made up of the blood capillary. This is the blood capillary, and then this blood capillary also allows the villi to do what? To absorb the glucose as well as amino acid. Remember that glucose is the carbohydrates, and then the amino acids will give us what? The proteins. So when we look into this structure, most of the nutrients which are needed by us, which are needed by the animal digestive system, will be absorbed because of what? Because of how the villi is made, because of how the villi is structurally adapted to do what? To perform its functions. So this is how absorption will take place in the villi, the absorption of what? Of nutrients. So all these structures are made are making the villi to be able, or to be possible to perform its function of absorption of the nutrients. And then now we go to assimilation. I have explained earlier on that when we talk of assimilation, we are simply talking about the absorption of what? Of nutrients into the cell of the body. In other words, there was an absorption of what? Of nutrients by the villi. Now, these nutrients also need to be absorbed by what? By the cell of the body. So that process is referred to as assimilation. So when we talk of assimilation, I'm repeating myself, grade 11s, we are simply referring to the absorption of the nutrients into the cells of the body. Now, we all know that the body absorbs required nutrients which are therefore necessary for the building of what? The building and the maintenance of what? Of all the compounds. For an example, we've got the muscle cells, which will absorb the amino acids. And remember now, the amino acids are the building blocks of what? Of proteins. In other words, the muscles of the cells of the muscles will absorb the amino acid, and then that amino acid will be converted into what? Into proteins, meaning that our cells will be having, or our muscle cells will be having what? Proteins. That is assimilation. And secondly, glucose will be absorbed by the cells of our bodies to provide energy, and this is usually happening during cellular respiration. As a result, our cells of the body are now having what? Are now having glucose, or the carbohydrates, and then these glucose or that carbohydrates will be needed so that we'll be able to do what? To do whatever the activities, because it will be providing us with energy. So this is the example of assimilation. Now, the part of the alimentary canal that plays a vital role in assimilation of the nutrients is nothing else but the liver. Remember, we have spoken about the liver, that is one of the largest organs in our bodies. So it is a part, or it's a gland that plays a vital role in the assimilation of what? Of nutrients by our body cells. Number one, what is the function? How does this liver plays a vital role in the assimilation of what? Of nutrients. Number one, it is because the liver is responsible for the metabolism of what? Of glucose. In other words, it is responsible to regulate the level of glucose. And then it is also responsible for deamination of what? Of amino acid. Lastly, liver is responsible to break down all the alcohol which was taken by our cells. It is also able to break down the drugs as well as the hormones. So these are all the roles of what? Of the liver. That is why we are saying it is an organ that plays a vital role in the assimilation of what? Of nutrients. I am not going to dwell much on the structure of a liver, because that's what we did 2 weeks back when we were doing the structure of the alimentary canal as well as the functions of all the body parts. Now, let's look now into we had absorption, we had assimilation of nutrients, and then the last process now will be egestion. We said, or I've explained earlier on, that when we talk of egestion, I am referring, or we are simply referring to the expulsion or elimination or excretion or taking out of what? Of all the undigested food. And most of the undigested food will be the large amount, will be the large or the big particles of the food that were not digested. Now, what is happening in the colon or in the large intestine? A large amount of water will be absorbed from the semi-solid waste. Now, this semi-solid waste is the food which is now in the what? In the large intestine, which was not digested, which was not absorbed, and which was not assimilated. So all those food particles will end up in our colon. Remember, we said the colon is the large intestine. Now all the contents which are in the large intestine. Remember, they've got those water particles. Now, what is happening when they get into the large intestine? The large amount of water will be absorbed by what will be absorbed by the colon. And then what is going to happen now with this content? This content will have less liquid, because much of the water, or most water, is now absorbed by the colon. So this content will be left with a little amount of water, and then that will make that will reduce the liquidity of all this content, which is already in the large intestine. So what is going to happen? After that undigested food will be temporarily stored here in the rectum. And then now when they are stored here in the rectum, they are now referred to as what? As feces. They are now stored there as feces temporarily. So meaning that if you are there temporarily, it means that you'll have to vacate, you'll have to leave the place anytime sooner. You are not there permanently, meaning that all this undigested food will be temporarily stored there, and we are no longer talking of undigested food. We are now talking of what? Of feces. So they will be temporarily stored where? On the rectum, or in the rectum. So what is going to happen now? There will be muscle contractions on the rectum. These, can you see, these are muscles. So these muscles will contract, and they will also make what? The muscles of the anus. Remember, the opening here is the anus. They will also make the muscles of the anus to do what? To relax. Remember that muscles are working antagonistically. In other words, when other muscle relaxes, the other muscle will do what? Will contract. So when the muscles of the rectum contract, and then the muscles of the anus will relax, and by so doing, they will be forcing what now? They will be forcing these feces to move out, or to be expelled to the outside. So that process is now called what? Defecation. So defecation is made possible by the what? By the contraction of the muscles of the what? Of the rectum, as well as the relaxation of the muscles of what? Of them of the anus. So that process is now called what? Defecation, when all these feces are expelled to the outside. So this is how egestion of all the undigested food particles is taking place. Now, when we look into this table, we can see that it talks about the food which is high in fiber. So when we talk of the food that is very high in fiber, it means that these food are the food which are having roughage. So roughage is an indigestible substance found in plant materials. For an example, cellulose, lignin, as well as pectin. So this is the table that is showing us the food which is having roughage. So we've got the lentils, we've got the blackberries, we've got the coconut, there's broccoli, there's oats, there's pear, there's raspberry, there's peas, avocados, and all of those. So this table is basically showing us the food which is having a high fiber content, and then the high fiber content will definitely bring what? Roughage into our alimentary system. Now, what is the purpose? What are the roles of what? Of roughage? Number one, they promote peristalsis. Remember, when we talk of peristalsis, we are referring to the downward movement of what? Of food. And this roughage will definitely decrease transit time. And secondly, roughage also prevents constipation, and it also prevents the hemorrhoids. And then the last function of the roughage is to soften the feces so that it facilitates defecation. Now, we have completed the first part of our lesson, which was absorption as well as assimilation. Now, the second part is homeostasis. Now, we need to understand the terminology before we can dwell much into its content. What is basically meant by homeostasis? Now, when we talk of homeostasis, we are simply referring to the tendency of all the living organisms whereby they are able to maintain the constant and stable environmental conditions, regardless of the external environment or of the changes that are happening in their external or in their internal environment. So we can safely say that homeostasis is the ability of the organism to maintain the stable or constant, something that is constant is something that is stable, to maintain the stable or constant internal environment despite of the changes that are taking place, whether internally or externally, whether they are taking place in their internal environment or in their external environment. But the organism should be able to do what? To maintain the constant environmental conditions. So that is basically homeostasis. Now, when we refer to negative feedback mechanisms, what are we talking about? So when we talk of the negative feedback mechanisms, we are simply talking about the mechanisms in human body that detect changes or that pick up the changes or the imbalances which are taking place inside our bodies, or which are taking place in our internal environment, and will be able to do what? To restore the balance. In other words, we'll be able to restore homeostasis. So let me repeat myself for the last time that when we talk of negative feedback mechanism, we are simply talking about the mechanisms in the human body which are able to pick up the changes or to pick up the imbalances, something that is not okay, that is happening inside our environmental conditions. And therefore, the body should be able to do what? To restore the balance. Now we are going to look into the steps or the stages of homeostasis. Now the first one, the first step, the imbalance will be detected. The imbalance will be picked up. In other words, if there's something wrong, that is happening inside the body, that the body will detect the change, will detect the imbalance. Secondly, and then the change will be sent to the what? To the control center, and then the control center will be stimulated. In other words, the control center will therefore receive the message that no, there is something wrong that is happening in this blood. And then after the control center has received the message or has stimulated, what is going to happen? The control center will therefore respond. In other words, it must do something. You have received the message. What must you do now? I must act. So that's how it is going to respond. And then how does it respond? It will send the message to the target organ or to the target organs. In other words, the organ that is responsible to rectify or to bring about the balance. That is the organ that is going to do what? To receive the message. So we are referring to such organs as what? As target organs. In other words, it is the organ that is targeted. It is the organ that will be able to do what? To bring about the balance in that body. And then the target organ will therefore respond. And then if the target organ responds, it means that it will oppose or it will reverse that imbalance. At the end of the day, the imbalance will be restored or will be restored. Now let us look into the homeostasis of what now? Of blood glucose. Now, I've just spoken about the target organ or the target organs. Now the target organs or the target organ that will have to detect or to respond to a change is the pancreas. So remember that the pancreas is attached there on the small intestine. So the pancreas is the target organ in these regards, is the target organ that will play a very vital role in the balance of what? Of glucose level in the blood. Now, what is happening? The pancreas has the islets of Langerhans. So you can see now that this is a pancreas with what? With its islets of Langerhans. So this pancreas is the target organ which will secrete two hormones. So these two hormones are the hormones which are balancing, which are regulating the blood glucose level. So the first hormone which will be secreted by the pancreas is the glucagon. Now, what is the function of glucagon? The function of glucagon is to increase the blood glucose level. In other words, when the blood glucose level is low, meaning that this is the hormone that will be secreted by the pancreas. Why the glucagon? Because it's the hormone that is able to do what? To increase the blood glucose level. And how is it making it possible? How does it increase the glucose level in blood? By doing what? By converting glycogen. Remember, glycogen is another form of what? Of starch. So it will convert glycogen, which is starch, into what? Into glucose. Glucose is what is needed because it was low. So this is the hormone that will be secreted by the pancreas to increase the blood glucose level. The second hormone that is secreted by our pancreas is hormone insulin. So what is the function of hormone insulin? Is to reduce or is to lower the blood glucose level. How does insulin lower the blood glucose level? By doing what? By converting this sugar, by converting glucose into what now? Into glycogen. Glucose into glycogen. In other words, the level of sugar will drop or will reduce. Now, let us look into this slide now. It tells us that when the blood glucose, when we talk of the blood glucose, so to say, when we talk of the blood glucose, we are simply referring to the amount of glucose in the blood. When we talk of blood glucose, we are simply talking about the amount of glucose in the blood. So meaning that there must always be a balanced amount of glucose in the blood. The amount of glucose in the blood should not be higher or should not be lower. It should be on its distinct level. Now, when the glucose is absorbed, maybe when it's absorbed in a blood, of course, from the digestive system, what is going to happen? Glucose that is found in blood is mainly taken by the cells of the body, and then it will be used during cellular respiration, and then which will do what? Which will release energy. We've been speaking about cellular respiration, glucose, and the release of energy. So that glucose which was taken into our blood will be assimilated by what? Will be assimilated by the body cells so that it can be used during cellular respiration so that it will be able to release energy. Now, if the blood glucose levels are too low, let me draw this line. Maybe this is the correct level of blood glucose. But here the blood glucose are too low. In other words, they are below the correct level, meaning that the blood glucose level is low. So the body cells cannot release enough energy because there's no enough glucose in those body cells, and therefore the body cannot be able to do what? To work, to function at its best. Why? Because the body or the blood does not have enough glucose. We need glucose to do what? To get energy, and then we'll be able to perform whatever the functions that we have to do. Now, if the blood glucose level is too high, remember I have used this line, meaning that this is the correct level of blood glucose. At first it was low, meaning that it was lower than the correct level. Now, if it is too high, meaning that it is above the correct level, meaning that the blood has too much what? Glucose. So what is going to happen now? Water is drawn out of the cell and into what? Into the bloodstream, meaning that all the body cells will now lose what? Will now lose water. And then where does this water go to? The water will go now into the what? Into the bloodstream. So what happens with the body cell? The body cell remains with no water because there was too much, or there's too much glucose in the what? In the blood. So the body cell will do what? Will definitely take what? Will withdraw all the water into the bloodstream. As a result, our body cells will remain with a low amount of what? Of water, which will definitely lead to what? To dehydration of the cells. Now, you know that when the body is dehydrated, person cannot do what? Cannot be able to function correctly, because the body is dehydrated. Why? Because of too much of glucose in them in the blood. Now there comes in now what? Our pancreas. There comes in the pancreas. Why is the pancreas coming in? Because it's either the level is too high or the level is too low. So meaning that there is a need of a pancreas to get in. Why? So that it can balance all these imbalances that are taking place in our blood glucose level. Now let us check now on how the pancreas does its function now in regards to the blood glucose. Now let's say, for an example, after a meal, the blood glucose level will do what? Will increase. Why will the blood glucose level increase after a meal? Because of maybe you have taken food which has too much glucose in it, or you maybe you use a drink which has too much glucose in it. So obviously what is going to happen with the level of glucose in the blood? It will increase. So if it increases, what is going to happen now? It will be the more glucose will be absorbed from the small intestine into the what? Into the blood. Meaning that the blood glucose level will do what? Will increase. Now the pancreas will do what now? Will detect, will pick up a change that there's something wrong in this blood. What is wrong in this blood? There's too much blood glucose in here. In other words, there's a high level of glucose in this blood. So meaning that the pancreas must now do its function. If there's too much glucose in the blood, what does that mean? It means that that high level of glucose needs to be dropped, needs to reduce. Now there comes in our pancreas. What is the pancreas going to do in this regards? It is going now to secrete insulin, hormone insulin. Why hormone insulin, not glucagon? It is because insulin is the hormone which lowers what? The blood glucose level. So there comes a pancreas, and then it secretes what? It secretes insulin. So why insulin? Meaning that the insulin will be able to convert this glucose into what? Into glycogen. It will be able to convert this sweetness, this sugar, this glucose into what now? Into starch. Remember, starch is not as sweet as glucose. So meaning that the insulin, this is how it is lowering the high level of glucose in the blood. By doing what? By converting glucose into glycogen. As a result, glycogen will be stored in the liver. The glycogen will be stored where? In the liver, in the form of starch, and then it will also be stored in the skeletal muscle in the body. Then that glycogen will be used to do what? To perform all the body the functions that we need to perform. And then the body cells are also stimulated to take up what now? To take up the glucose, and then in that results, what is going to happen with the level of glucose in the blood? It will be lowered, and then it will then return to a normal level. And then secondly, let's say the blood glucose levels decrease, maybe because the body cells are constantly using the glucose during cellular respiration. When we do whatever the activities, we need energy. So the body cells are constantly using that glucose for cellular respiration. Definitely that will do what? That will lower the amount or the level of of glucose in our blood. Now what is going to happen? It means that when the blood glucose levels decrease, again the very same pancreas will detect the change that there's something wrong in this blood. What is wrong now? The change is that there's little or there's too low, the blood glucose level is lower than it is expected. So therefore the pancreas will release hormone glucagon. I want to pause here. I will continue after here, grade 11s. I don't want you to mix the following words: glucose, glycogen, let me rewrite it: glucose, glycogen, and glucagon. Can you see all of them are starting with glucose? They are all starting with GL. So glucose is what you are talking about, the amount that is in the level of the concentration that is dissolving in blood. Glycogen is it's a starch. It's in a form of starch. Glucagon is a hormone. Is a hormone that increases the blood sugar levels. So I do not want to grade 11s to mix up all these terminologies. Now let me go back to where I was. I was talking about the pancreas that will secrete hormone glucagon. And then that hormone glucagon, what will it do now? It will convert glycogen into what? Into glucose. Therefore, the amount or the level of glucose in the blood will increase to the required or normal, or to the it will get back to its normal level. Now, insulin gives us or produces glycogen. Glucagon produces or secretes glucose. These two are the hormones. These two are the hormones. The other one releases glycogen, which is a starch, and then glucagon releases glucose, which is sort of a sugar. So I do not want you to confuse all those words. Now let's quickly look into this diagram. It also explains the homeostatic of what of blood glucose. Now let's say there is high blood glucose level, maybe after eating whatever the meal. So what is going to happen? Pancreas will secrete insulin. We all know by that, by now. And then insulin will convert glucose into what? Into glycogen. And where will all this conversion happen? In the liver. And then what is going to happen? The cells will be stimulated, and then they will be able to pick up what? The glucose. And then what is going to happen? It means that most of the glucose was picked up or were transferred into the cells. And then what is going to happen now? There will be little amount of what? Of glucose in the blood. So what does that mean? It means that the blood glucose level will go back to the normal. It has now decreased. And then now, if the blood glucose level drops, maybe because of cellular respiration activities, so what is going to happen? The very same pancreas will secrete glucagon, which is the hormone that that increases the level of sugar by converting glycogen into glucose. And then if glucose is high, it means that the glucose levels will increase, and then it will then go back to the normal glucose level. And then here we are also having, I just put this just to reinforce this homeostasis of blood glucose. Step 1, glucose levels in blood, if they are above the normal level, pancreas will be secreted. Yes, after it has been secreted, it will now stimulated, so to say, it will secrete hormone insulin. Hormones insulin drops or lowers the blood glucose level, and then insulin will travel in the liver, and then by so doing it will be converting glycogen, it will be converting glucose into glycogen, and then what is going to happen? The level of glucose will decrease, and then it will return to normal. And then here we are talking about the level of glucose being low or decreased below the normal levels. The very same pancreas will be stimulated, and then remember when we talk of a pancreas being stimulated, meaning that it receives, it picks up the imbalance, so it gets stimulated, and then when it's stimulated, it will have to secrete which hormone now? It must secrete glucagon. Why? Because the sugar is low, so it needs to secrete the hormone that will increase the sugar in the blood. So what is going to happen? The glucagon will travel again into the blood to the liver, and then what is going to happen? It will definitely convert glycogen into glucose. So what is going to happen to the level of glucose in the blood? The level of glucose in the blood will increase, and then that will return to the normal level. Yes. So the last part under homeostasis is the diabetes mellitus. Now, when we talk of the diabetes mellitus, we are simply referring to the disorder which is characterized by the blood glucose levels resulting in the increased fatigue, which is basically tiredness, will also result in dehydration. Maybe the body cells do not have enough water, and the lack of it will also result into the lack of energy. Now, there are two different types of diabetes mellitus. Type 1 is usually inherited disorder. In other words, it is genetical. Or if it's not genetical, it can be caused maybe by a loss of insulin production, producing cells. Sorry, it will be caused by a loss of insulin producing cells in the body. In other words, the pancreas is no longer able to produce the insulin. So that can also be the cause. It's either genetical, you can inherit it from the parents. If not so, it is because now the pancreas is no longer able to to produce the insulin. That is the cause. And then how is it treated? This is a lifelong disorder. It means that the daily injections of insulin are required, and a person needs to have that special diet which will at least balance the sugar levels. And then the type 2 of diabetes, it is also caused by insulin resistance, whereby the body does not produce or react to any insulin given. So usually this can also be a result of poor lifestyle choices. And then the treatment, again, you need to have to maintain a balanced diet and regular exercise as well as medication. Now it's activity time, grade 11s. Before I can start with my questions, I've already projected the first activity, but before I can move forward, I just want to hear from you if there's anything that you need clarity on, if there's anything that you want me to explain, if maybe there's something you did not understand. I am giving you a minute to ask questions before I ask you questions. I will see by raising of hands if there's anything that is coming from any school, any learner. that you need clarity on. Okay, silence means consent. Let us continue. I've got a multiple choice question here. Let me quickly read the phrase, and then we'll go to the question later. Irritable bowel syndrome, which is in short IBS, is a medical term used to describe a disease of digestive systems. Symptoms usually occur after certain foods or drinks are consumed. It can cause sudden and severe diarrhea. What consequence can this have for a person? So the first option, too much water and nutrients will be absorbed in the digestive tract. B, too little water will be absorbed, but the nutrients will be absorbed. C, too little nutrients will be absorbed, but water will be absorbed. Or D, too little water and nutrients will be absorbed. So what is the correct option then? Is it A, is it B, or is it C, or is it D? I am not giving you answers. I'm waiting for you to respond. Grade 11s. I don't see any hands. Or am I alone in this class? Where are my students? Where are my learners? Okay, without any waste of time, let us quickly look into the option. Definitely there will be too little water and nutrients will be absorbed. So the answer will be D in that regards. Activity 1.2 is the column question whereby you state whether the option is A only or is it B only, both A and B or none. So we are having column 1 and column 2. Column 1.3.1, the substances that need to be digested before absorption. Is it amino acids? Is it glucose? Is it both of them or none? Grade 11s. Substances that need to be digested before absorption. Kindly raise up your hands. Is it A only, B only, both A and B, or none? Kindly raise up your hands if you want to respond on that question. I do not see any hands. I do not even see my classes today. I'm only seeing the screen. So, but if you raise up your hand, yes, I will be taken into. How many schools do we have here? Jenny, Fenzami, oh, I can't pronounce that. Lisigo, Khaswane, Matile, Hemina. I know Mem Matile from Jordan Secondary School. I'm sure you are with your learners. Mpho Kumete, Samukelisiwe. Yes. Mem Matile, because I know you, please let your learners answer. Is it A only? Is it B only? Both A and B? I'm sorry to put you on the spot. Okay. I am continuing. So the answer for that is none of those. And then a lymph, 1.3.2, a lymph vessel in the vellus of the small intestine. Is it the lectile? Is it the lymphatic node? Is it none? Is it both of them? So I'm waiting for the answer. The lymph vessel in the villus of the small intestine, is it a lectile or the lymphatic node? None of them or both of them? Yo, my grade 11s. I'm not sure whether you have not yet touched this chapter or you are not, even if you did not do it with your teachers as yet, but it's what we did for the past hour. So I'm waiting for the answer. Okay, because we've got so many activities are waiting for us. So the answer is the lectile. The enzymes secreted by the pancreas, is it the proteins or the carbohydrates? I'm giving you the answer, both of them. The structure where the chemical digestion does not take place, where the chemical digestion does not take place. The chemical digestion does not take place. Is it esophagus? Is it the large intestine? Both of them or none? So the answer is both of them. There's no chemical digestion that taking place in the esophagus as well as in the large intestine. The diagram below shows a structure or associated with the digestive system. So this is the structure. The celiac disease is a disorder that makes human bodies react to gluten. Gluten is a protein found in wheat, rye, barley, and grains. The response by the immune system eventually damages the structures illustrated in the diagram along the side. Now discuss the effect of this disease in the human body. Discuss the effect of this disease in the human body. What is this disease? This disease, they are saying that it damages the structures. In other words, it damages the villi. So if the villi is damaged, discuss the effects of this disease in the human body. I'm giving you 30 seconds to answer this. Okay, and this is very, very possible. Remember, you must know the function of what? Of the villi. We said the function of the villi is to do what? Is to absorb nutrients. So if the villi is damaged, is it any way whereby the nutrients will be absorbed, whereby the part that is responsible of absorbing those nutrients is damaged? So what does that mean? So this question definitely needs you to discuss the effects of this disease in the human body. Number one, the body will not be able to do what? To absorb nutrients, because the function of the villi is to absorb nutrients. So even if you give us the examples of the nutrients, your minerals, your vitamins, and then they will run the risk of what? Of malnutrition. If the body does not get all the nutrients it requires, meaning that they will be having that risk of what? Of malnutrition, and then which will lead to what? To retarded growth, meaning that the growth will be very, very slow, and then it will also lead to fatigue as well as weight loss. So these are the Mahala marks. You can definitely not afford to lose such Mahala marks. Just imagine 3 marks. And then second question, activity 2, the graph below shows the results of glucose tolerance test on a healthy individual, which is person A. Healthy individual is person A, and then it is symbolized by the triangle lines. And then on a diabetic person, which is person B, and then person B, is given the square lines. After fasting for 10 hours, they were given a drink of glucose solution containing 50 gram glucose. The amount of glucose in their body was then measured every 30 minutes for the next 3 hours. So we are having the results. The graph shows the results of glucose tolerance test on a healthy person, which is person A, and on a diabetic person, which is person B. And then on our y-axis, we are given the blood glucose levels, and then there are the units from 0 up to 300. And then on the x-axis, we are given time in minutes from 0 minutes to 210 minutes. Now let's quickly look into the questions which are based on that. What is the normal concentration of blood glucose? What is the normal concentration of blood glucose? So we are given what the normal. So this is the normal. So they want to know the normal concentration of blood glucose. I'm giving you a second to answer this. I'm not giving you the answer. Please try to give us the answers. Even if you are not sure, just give it a try. We are all here to learn. What is the normal concentration of glucose? So you can get your answer from the graph grade 11s. Remember, this is the normal. You see, the normal is the circled ones. So what is the normal glucose level here? 1 mark. Even a person who was not in this class, if we can just ask any person who was not in this room and we ask him or her to give us the answer, I'm telling you, they can give us, because they just look into the graph and give us the answer. Okay, the answer, it's there. It's 100. Here it is, and I've been pointing at it. Yes, the second question, what was the greatest concentration of glucose in the diabetic's blood? The diabetic, where is it? Here it is. So they want, this is the square one, this is the diabetic person. They want to know the greatest concentration, the greatest. You also look into the graph, the highest value there. What is the highest value? Without any waste of time, the highest value, there it is. It is 300. And then what happens with excess glucose in the blood? What happens to the excess glucose in the blood? It will be stored as glycogen in the liver. Remember that if there's too much blood in the liver, that glucose will be converted into what? Into glycogen, and then it will be stored as that. And then 2.4, from the graph, again, meaning that you're going to get the answer from the graph, determine how long it will take for the glucose concentration, A, of the healthy person to return to the level when the glucose solution was consumed. So how long will it take on the what? On a healthy person. So which graph represents a healthy person? The triangle one. So this is the triangle one. So how long? When we talk of how long, we are referring to a time, meaning that your answer should be around or along the axis values. So how long will it take for a normal person to get into the normal level? I'm waiting patiently. So how long will it take? Grade 11s. I'm moving forward. So this is the answer. How long will it take? It will take them 150 minutes. Here it is. It will take them 150 minutes for 2 marks. And then how long will it take for a diabetic person to return to the level when glucose solution was consumed? Remember, the diabetic person is represented by square, so that is the square, and then it will take about 210. Can you see? It will take 210 minutes, so which is basically 3 hours and 30 minutes. What effect will be injecting insulin into the diabetic person have on the results of the test. So I'm going to give you answers because, yeah, we are definitely out of our scheduled time. What effect will be injecting insulin into the diabetic person have on the results on the test? So the effect is that the insulin will lower down what the blood glucose, and then what is going to happen? The concentration of diabetic will be back to normal. Will be back to normal, and then it will also shorten the time it takes for the blood glucose concentration to return back to normal after ingestion. Explain briefly why insulin, which is a protein, is injected into a diabetic person rather than given orally. It is because an insulin is a protein, and therefore if it's digested in it will be digested in the digestive system of the human, and therefore it will not be absorbed as insulin, but it will only be absorbed as what? As amino acid. So that person is as good as not getting the insulin. So it's better for them to be injected rather than taking the insulin orally. Which patient is diabetic? Oh, so this is a different scenario. Let's quickly look into the statement. An oral glucose tolerance test is used to determine if a person is diabetic. This test was performed on 2 people. So we've got patient 1 and patient 2. After fasting for 12 hours, each person was given the same glucose solution to drink, and then their blood glucose levels were measured every 30 minutes for 2 hours. The results of the investigation are shown below. Now the question says, which patient is diabetic? Is it patient 1 or patient 2? Which one of the two is diabetic? Definitely it will be patient 2. Patient 2, why? Because we are checking on the glucose level. It goes up to 200, meaning that this is the person who is diabetic. Give a reason for your answer. I think I've already answered you. Patient 2 has an elevated blood glucose level after 120 hours. There's still that high level of glucose, whereas patient 1's blood glucose has returned to what? To normal. How long does it take for the blood glucose of patient 1 to return to normal? So where's patient 1? Patient 1 is the triangular one. How long does it take for his blood or for his or her blood level to return back to normal? So definitely you have to look into the x-axis. That's where you're going to get the time frames. So it will only take 120 minutes to go back to normal. 3.4. What is the name of the hormone that increases blood glucose level? So we've spoken about that. So the hormone is glucagon. And then what is the hormone that decreases or lowers down the blood glucose level? Is insulin. So that takes us to the last or to the end of our session, grade 11s. I'm sure we'll be able to answer all the questions based on today's topic. So you'll be able to perform very, very, very well in your June examinations. Until we meet each other again, have a pleasant day. Bye-bye.